So you probably noticed in those previous examples how convenient it was to use the properties of logarithms to simplify a function before having to differentiate, because it can get really ugly if you don't do that. So could we do this even if logarithms weren't involved in the first place? And the answer is yes. So there's a type of way to differentiate that is called logarithmic differentiation. So remember, with an equation, as long as whatever you do to one side, you do the same thing to the other side, you're keeping that equation balanced. So to do logarithmic differentiation, if you have a very complicated formula that doesn't involve logarithms, you first will take the logarithms of both sides. Then you'll use properties of logarithms to expand as much as possible. And then at that point, we're going to have to differentiate implicitly. So let's look at this in action. Find the derivative of y equals the fourth root of x squared plus 1 over x squared minus 1. So in this case, if you wanted to, you could go through and do the chain rule by taking that fourth root as the outside function and the inside function being x squared plus 1 over x squared minus 1. So I do implore you to actually, if you want to, pause the video and go ahead and work out the derivative that way. And then come back and I'm going to show you how to do the same thing but to find the derivative, but now doing it using logarithmic differentiation and how we'll get the same answer. So if I did this using logarithmic differentiation, and I'm going to do that just because I see if I had a log in front of here, this would be a lot. I can expand this out using those properties of logarithms before taking the derivative. So I'm not having to deal with the quotient rule, the chain rule all in one. Okay, so if I do that, again, whatever you do to one side, as long as you do it to the other, it's okay. So let's take the natural log of both sides. And then once I do that, let's use those properties of logarithms to expand this out. So I'm going to get the natural log of y equals, okay, so the natural log of, let's write this all as to the 1/4 power. All right, so that gives me the natural log of y equals, I can move that 1/4 in front, the natural log of x squared plus 1 over x squared minus 1. Okay, now I can use, so now at least I've gotten rid of that gross fourth root. But now let's go through and expand this logarithm out. So if I expand this out using that quotient property, this becomes the natural log of x squared plus 1 minus the natural log of x squared minus 1. And we have to remember that that 1/4 is applied to that entire thing. So I'm going to go through and just distribute that through because that's going to make it a lot simpler when I go to do the derivatives. All right, so now I've got this. So now I can go through and use implicit differentiation to find the derivative. All right, so if I was doing that, we're going to start with, so the derivative, take the derivatives of both sides. So the derivative of the natural log of y equals the derivative with respect to x of 1/4 natural log of x squared plus 1 plus the derivative with respect to x, minus of the natural log of x squared minus 1. Okay, so at this case, using implicit differentiation, so we're going to have 1 over y, because I have to use the chain rule here because this is a function of x, times the derivative of y, which is going to be dy dx, equals, so 1/4 times, so using the chain rule here, the derivative of the outside is 1 over x, but I have to evaluate it at the inside function, so it's 1 over x squared plus 1 times the derivative of the inside function minus, oops, and this should have been a 1/4 here, so minus 1/4 times the derivative of the outside functions evaluated at the inside times the derivative of the inside. So at this point, let's go through and kind of simplify this out a little bit. So I'm going to have 1 over y times dy over dx equals, so I've got a 2 and a 4, so that's going to turn that into a 2, so I'm going to be left with x over 2 times x squared plus 1 minus, same thing here, so I'm going to be left with x over 2 times x squared minus 1. So now my whole goal is to find the derivative of y with respect to x. That's what I was solving for. So to get that dy dx by itself, we're going to get rid of that y. We can multiply both sides by y to get rid of that. So that's going to leave me with dy over dx equals y times x over 2 times the quantity x squared plus 1 minus x times the quantity 2 times x squared minus 1. And I know what y is in terms of x, so I don't have to leave it like this. I can substitute in. We know y equals this quantity, so let's substitute that in. So we're going to get the 4th root of x squared plus 1 over x squared minus 1, since that's what y equals, all times x over 2 times x squared plus 1 minus x over 2 times x squared minus 1. Still looks really gross, but it is way less steps than if we would have gone through and just did it the way with using the chain rule and the quotient rule all together. Find the derivative of y equals the square root of x times e to the x squared times the quantity x squared plus 1 to the 10th power. So you could go through and differentiate this without using logarithmic differentiation. You're just going to have to apply the product rule and the chain rule multiple times. I'm going to go through and use logarithmic differentiation just because in looking at this, it looks like if I use the logarithmic properties, I can make that right-hand side a little bit easier to differentiate. So let's start with that. So if I take, first let's take the logarithm of both sides. So I get the natural logarithm of y equals the natural logarithm of the square root of x times e to the x squared times the quantity x squared plus 1 to the 10th power. So now I'll go through and I'm going to use properties of logarithms to separate all of these out. So I get the natural log of the square root of x plus the natural log of e to the x squared plus the natural log of x squared plus 1 to the 10th power. Okay, let's keep on going. So remember that the square root of x is the same thing as x to the 1/2 power. So I can move that 1/2 out in front, and this becomes just 1/2 times the natural log of x. I can use that product or power property here where that x squared can go in front, and we'll get x squared times the natural log of e, and recall the natural log of e is just 1, so that just simplifies to x squared, plus 10 times the natural log of x squared plus 1. So now I'm in a situation where this is going to be much simpler. I'm not going to have to use the product rule, and I'm only going to have to use the chain rule a couple times. So let's go through and take the derivative of both sides. So the derivative with respect to x of the left-hand side and the derivative with respect to x of the right-hand side. Okay, so if I first did the derivative with respect to x of the natural log of y, that's going to become 1 over y times dy over dx. Again, because we're taking the derivative of the outside function, which is the natural log function, so that becomes 1 over the inside. I'm having to apply that chain rule, so it's 1 over x. In this case, it's going to be 1 over y is the inside function, times the derivative of the inside function, which is dy dx. Okay, and then that equals, so the derivative of 1/2 ln of x is going to be 1/2 times 1 over x. The derivative of x squared is 2x. And the derivative of 10 times the natural log of x squared plus 1, so that's going to be the same thing with this chain rule here. We've got our inside function and our outside function, so there's our inside. So the derivative of the outside function would be 1 over x, but I have to evaluate it at the inside, so it's 1 over x squared plus 1 times the derivative of the inside, which is 2x. So this is going to simplify to 1 over y times dy dx equals 1 over 2x plus 2x plus 20x over x squared plus 1. Now at this point I can multiply both sides by y so that I can isolate that dy dx. So when I do that, I get dy dx equals y times this entire quantity, 1 over 2x plus 2x plus 20x over x squared plus 1. And now at this point I can substitute in what y is since I have it defined in terms of x. So that's the square root of x e to the x squared times x squared plus 1 to the 10th power, and then times this entire thing. So 1 over 2x plus 2x plus 20x over x squared plus 1. Find the derivative of y equals x to the root x. So looking at this one, there actually is no way to differentiate a function like this unless we are using that logarithmic differentiation. So let's go through, and before I try to differentiate anything, let's do the logarithms of both sides. And hopefully I'll be able to get this into some functions that I actually can differentiate. So when I do that, I'm going to use that property of logarithms, which allows me to move that power, which is the square root of x, down. And now I have this in terms of something that I can actually evaluate. I can find the derivative of the square root of x, and I can find the derivative of the natural log of x. So now I've gotten this function into a form that we can do this differentiation on. So now let's do that. So take the derivative of both sides, and on the left-hand side, taking the derivative of the natural log of y with respect to x. So again, this is where we apply the chain rule. So the derivative of the outside function, the natural log, would be 1 over x. In this case, it's going to be 1 over y because we have to evaluate it at the inside, which is y, times dy dx. Okay, to find the derivative of this, I've got two functions that are getting multiplied together. So we're going to use the product rule. So that's going to be the square root of x times the derivative of the natural log of x plus the natural log of x times the derivative of the square root of x. All right, so this becomes 1 over y times dy dx equals the square root of x times 1 over x, since the derivative of the natural log is 1 over x, plus the natural log of x times the derivative of the square root of x. The square root of x is 1 over 2 root x. Okay, so now that I have this all kind of down like this, my whole goal is to solve for dy dx. So what I need to do is get rid of that y. So to get rid of that, we're going to multiply both sides by y. That's going to cancel that out, and we're left with dy dx on the left. And then on the right, we have y times the square root of x over x plus the natural log of x over 2 root x. Now what we'll do, we already know what y is in terms of x, so I can substitute that in. And I'll have everything in terms of x. So dy dx equals x times the square root, or x to the square root of x power times the quantity square root of x over x plus the natural log of x over 2 root x. Find the derivative of y equals x to the cosine of x. So I'm in that same situation here where I have x to a power of a function, and I don't really have any differentiation rules that allow me to do that. So what we're going to do instead is do logarithmic, use some properties of logarithms to get this into a function that I can differentiate. So if I take the natural log of both sides, I get the natural log of y equals the natural log of x to the cosine of x. And now using that power rule, that cosine of x can come in front. All right, so now I'm in a format where I can find the derivative because I know that what the derivative of cosine of x is, it's negative sine of x, in the derivative of the natural log of x, which is 1 over x. So we'll use logarithmic differentiation. All right, so let's take the derivatives of both sides. So dy dx of ln of y equals the derivative, sorry, this should be derivative with respect to x of the natural log of y equals the derivative with respect to x of cosine of x times the natural log of x. So this becomes, on the left, I'm going to be left with 1 over y times dy dx equals, I'm going to have to use that product rule here. So I'm going to get cosine of x times the derivative of the natural log of x plus the natural log of x times the derivative of cosine of x. Okay, so that is going to end up becoming the cosine of x times the derivative of the natural log function is 1 over x plus the natural log function times, so the derivative of cosine of x is negative sine of x. All right, now my whole goal is to solve for dy over dx. So to get that by itself, let's multiply both sides by y. So that leaves me with dy over dx on the left equals y times cosine of x over x minus the natural log of x sine of x. And now that I have it in this format, I know what y is in terms of x. It's x cosine of x times the cosine of x over x minus the natural log of x times the sine of x. So there is my derivative function.